Alright guys, so here we go. We're going to talk about alkanes as fuels, and essentially this comes down to the volatility. Now, we'll talk about volatility in a minute, but first we need to talk about dispersion forces, which are what affects volatility. Now, the dispersion forces we talk about, generally, we can refer to as van der Waals forces. You can call them that if you want, or you can just call them weak dispersion forces. Either way is fine. Now, the way these dispersion forces work is, on average, and this says argon, but you can imagine this to be any alkane you want. On average, alkanes are non-polar, which means they've got an even spread, even distribution of electrons all around the molecule. But any instant that you look at it, because electrons are moving and they repel each other, etc., there will be a dipole, which means a differential between the positive end and the negative end. So one end will have more electrons than the other. That will be the negative end, and this creates an instantaneous or temporary dipole. These are attractive. Now, this tends to keep the molecule holding together as a liquid, and keeps it in that liquid range. Now, the stronger the dipole, the stronger the attractiveness, the more energy you need to put in to make it change state, so make it turn into a gas. Alright, so dispersion forces, they increase as molecular weight increases, we just said that, and this then leads into the boiling points increasing. Now, volatility is the ease with which a liquid turns into a gas or a vapor. So, if the boiling point increases, this means it's harder to turn into a gas, volatility decreases. As boiling point goes down, volatility goes up. With alkanes, as the molecular weight decreases, volatility goes right up. Volatility goes down as the molecular weight goes up. And that's because, as we said, with a large one, there are more electrons to end up on one side, therefore your dispersion. So, that's more electronegative on this side, much, much less over this side, and that gives you a stronger dispersion force. And we can see this if we just graph if we were to graph these, they would look like that. So methane, it's minus 161, ethane's 88.6, propane's 42.1, and so forth as we go up. So now alkanes as fuels. Here we have a fractionating column, an industrial fractionating column, where smaller molecules, because of their low boiling point, high volatility, they go up the top, and that's where they stay as a gas, and further down you've got to put more and more energy. Now remember, as it rises, it uses up some of its energy to rise, so it cools down as it comes out. Alright, so most common fuels are alkanes. Basically, a natural gas is 75 to 90% methane, ethane 5-10, and propane and butane make up the remaining part. And it's also got stuff like nitrogen, water vapor, carbon dioxide. Now you've got LPG, which is majority propane and or butane. We've got petrol, kerosene, diesel, and remember petrol is very volatile, kerosene less so than that, and diesel less than that, and we use these in transport and industry. Alright, so generally these, like your petrol, kerosene, and diesel, they're mixtures of carbon compounds. They're specific mixtures, but they're mixtures, and those are, again, mostly alkanes. So while we talk about carbon compounds, we should call them hydrocarbons. And there is variation. For example, the diesel you buy in winter, particularly somewhere cold like where we live, in Orange, the diesel you buy in winter is a different diesel to the diesel you buy in summer. And that's because they react differently to the cold weather. Alright. Petrol, though, is generally alkanes from C6 to C22. Alright, safety issues. Now, one of the dramas with using alkanes as fuels is that they are volatile. This works because it means we can release a large amount of energy from each reaction, but it also means that we can have issues with it. So when there is electric charge, as happens to this poor lady down here, or an extra flame, which is what happens down here. We can have all sorts of dramas. Alright, so they have a low boiling point, high volatility due to weak intermolecular forces. You guys are getting really good at differentiating between inter and intra, so that's fantastic. As they turn to gas easily, they have a high pressure of vapor. In other words, that means there's a lot of vapor sitting directly above the surface. So if the vapor ignites, well then that causes more of it to turn into gas because the temperature rises, and so it feeds into itself. And the more volatile it is, the faster that reaction happens and it turns into an explosion. So they have a low flash point often. That's the temperature which it will do that, and that's often below room temperature. A low flash point means that it's very easy to ignite it. For example, the flash point of something is the temperature which it will start to combust. Okay, and this means they're explosive, so that's not cool. Well, I mean, you know, it's essential for using petrol. Okay, so you've got to, how do you handle them? You're going to store them at low temperatures, well ventilated areas, because they are going to produce gas, and if you produce that gas and some of it can't be released, the fumes build up, and that's a fire hazard. It'll also increase the pressure inside of the liquid, and that's no good. So you want to avoid handling them or inhaling their vapors, because most of these, one of the reasons that they combust so well is that they're also very, very reactive. So definitely no naked flames or sparks. Foreign fire extinguishers, water won't work because water will just spread the fire. Strong containers that are regularly checked for leaks. If you go take your gas bottle to the petrol station to have it filled up for a barbecue, one thing that should happen, it doesn't always happen, is it will be checked for a leak by the guy who's filling it up, but not necessarily. You might be there working for minimum wage and not care at all, which is one of the reasons the swap and drop setup is pretty good, because those are taken away and they're checked by professionals. And you want to keep it full to prevent having that room for vapors to build up. So if the tank is full, there's no room for that vapor to build up just above it. Alright, look, don't inhale the vapors. Some are carcinogenic, most are toxic. Alright, that's it. So as you see, there's a lot of dangers involved with it, but if we use them correctly and they tend to be fairly safe.